things come in three, they say. Well, it's certainly true in this case. This is my coffee machine. It's gone wrong, badly, and for a coffee addict like me, it's a complete disaster. And of course, it happened when I was about to serve coffee to a guest. Now, I've repaired it, it's fine, and in this video I'm going to show you the key points, and that's because it took forever to do. Partly because I was fumbling around a little bit trying to figure out what was wrong, and I had to order parts as and when I found I needed them, but also progress was halted due to two other disasters. Firstly, I'd injured my shoulder some while ago, and that flared up soft tissue injury, making lifting impossible, and it necessitated a visit to the physio. Finally, at least I hope finally, a third disaster when my hand and a bandsaw blade intersected. After a visit to A&E, there was about a 3-week loss of dexterity in the hand, and again, an inability to move heavy items like coffee machines. Anyway, enough of my whinging, let's look at the problem and see what I did about it. So, what's actually happening with this is it's overheating. The top of here is getting really, really hot. I mean, it's supposed to get warm, because it's a cup warmer, but it's getting really, really hot. And normally what happens is you put it on, the temperature runs up to 93 degrees or 94, whatever you've got it programmed for, and then it stops, the light goes solid, these lights down here come on so you can dispense one or double basket, whatever it is you're dispensing. So I've had a good look around, and one of the sites I've been looking on is this guy here at West Coffee Gear. They've got quite a lot of information about repairs, and also there's been quite a lot of forums that I've looked on as well for this self-same problem, because what happens is it gets to 93, it continues to 94, 95, 96, and then it pretends it's gone to 93, but the heater is still operating, it's still getting hot. And if I turn it off and then turn it on again, it immediately shows a temperature reading of 100 centigrade. And it absolutely shouldn't be doing that, and it's also making some gurgling noises while it's heating up, and normally it's pretty much silent. So those are the symptoms, and it of course doesn't let me dispense coffee, but it does let me dispense hot boiling water and steam. The general consensus in the various forums and things like that seems to be that there are two likely problems. This is a couple of days after a descale, and the consensus is that there are some probes that go down into the boiler to measure water positions and things like that, and one idea is that those probes are mucky, basically are not sensing properly, and another one actually is that the pump isn't actually pumping the water properly. Now this does have a service menu, and to get into that you basically press these two buttons and hold down that, and then it comes to the service menu, and you can look up, it's got 32 error codes, and you can look up how many counts of each of those there are. And there are some counts regarding the pump is pumping but not much water is coming through. There are some errors regarding the high water sensor has sensed and the low water sensor has not. So yeah, that doesn't make much sense. So I've ordered myself two things. So these, which are basically O-ring kits, and this, which is a new water pump. And for those interested, this is type EX5FM, and this should be a drop-in replacement for what's already there. So it's got a reverse valve here built in, and yeah, basically high pressure end, low pressure end, and fingers crossed that will be correct. So the plan is to take it apart, take out the water level sensors, clean those, put them back in, take everything out of the boiler essentially, replace all the O-rings, and also possibly, I'm less sure about this, possibly replace this. Okay, so the two screws I'm missing, I reckon, are under here. So there's a little lamp there, and then next to it there's a very, very recessed Phillips head screw. So I'm going to have to go and get a very long Phillips screwdriver, I think, and hopefully I've got enough room to just kind of push that up through here and into the screw hole. And what you can probably see is the top is now loose. Yeah, the lid just folds back out of the way. So we've got the tube here that feeds water out of the top. While this is off, I might well take the opportunity to very quickly just clean the inside. There's a little water door here. You can add water without having to take the thing at the back, and I actually use that all the time. Let's see if I can't persuade the top-down camera to give us a bit of a view. So I'm not actually taking the top off, and the reason I'm not taking the top off is there's a lot of cables going through to various devices there. So we've got our two boilers, one just here, one just here. Happily, there doesn't seem to be much sign that water has been coming out. There is a little bit of a scale on here. Yeah. So we do have in here quite a lot of complexity. There's a heat exchanger as well as just two boilers, because you might imagine it's just two boilers, and one boiler turns on when you want steam and hot water, and the other one turns on when you want to output through the group head. To get actual coffee out, the group head is directly under here. But that isn't the case. There is a heat exchanger between them because we need to maintain very accurate temperatures. This section here definitely needs a few O-rings replacing, there's no doubt about that. The pump, vibration pump, is way down here. Really, really difficult to see from this angle. Not sure how easy that would be to replace, to be honest. I think another back panel might have to come off in order to do that. So for the moment I'm going to start off by... So these tubes are fine, I'm just going to leave them alone. These appear to be the element, so I'm also going to leave those alone. Because, you know, really? Do I really want to think about taking that off? No. And yeah, on the side, unfortunately, we've got an awkwardly placed thermal detector, but I'm kind of okay with that. So I'm going to start off by pulling these two, which I believe should just be like depth sensor type things. So let's start off with this first one. First of all, take the clip out, and hopefully we can withdraw it, and then we have a nice simple sensor with no length to speak of, which does actually look exceptionally clean, I have to be perfectly honest. So just remove the O-ring. Grab the appropriate sized O-ring from the kit and run it on here. We then need a teensy bit of grease, and the reason we need grease is to ensure that this O-ring goes in without any distortion. We want to wipe a tiniest bit just on there. Verify this is completely clean. Reinsert, push home. And insert the retaining clip. Number 1 done. Okay, so that's the top two easily accessible ones done. We can remove these and put these little red silicons on it, but I'm not really seeing any issue with these particular ones. I'm seeing a bit more issue on this side over here. That is to be sure. Yeah, so you can't really see, I don't think, on the screen, but I will try and zoom in, but the problem with zooming in is we're just going to kind of lose focus, really. Hopefully you can see that. Now there are you can see that it kind of looks like kind of dried out and a bit blackened, and there are lines of cracks all the way around it. So we're going to pop that off. Lovely. So we know that's now clean. No residues on it, nothing like that. And the red washer, brand new red washer. Pop it on. A little bit of the silicone again. Let's pop this on with a cotton bud or a Q-tip or whatever it's called in your relevant country. And I'll also just wipe the seating just to be sure we're nice and clean in there as well. Yeah. So I like to just make sure that I've removed the surrounding crud, at least a little bit, so that it can be viewed next time if it needs to be. Yeah, that's it now. Nicely clipped in place. And just got to be a bit careful not to drop any of these, because not that easy to get at. Okay, hopefully that's good. Let's do the white one, the yellow one rather. Now this one has a bit of scale evidence and things like that on it here and there, nothing too bad. I've been round, I've pretty much cleaned everything and done all the tubes and put new O-rings on. There is actually a water inlet on the side of this boiler, which is really awkward to get to, and I've had a good look at it and decided not to play around with that one because it's just really awkward. And although I do understand that quite a lot of people would want to change it as well. You can see it going in on the left hand side of the boiler, just underneath that plate. So in cases like this, where I'm kind of fumbling my way through something, working step by step, trying to solve problems, I do like to do one piece of work, like replacing O-rings and cleaning everything, cleaning sensors and things, and then actually test it and see if that's made a difference. So it might not solve the whole problem, but at least it gives you a good step forward. And that's exactly what I'm doing here. So we'll see how this goes. Now the good news is, it's very quiet. Certainly, the first time I was running this, I was hearing boiling water at this point. So for 93, then this being stable, and it's still flashing, still heating. That's off, stopped heating, supposedly, but this is still flashing, which means can't dispense coffee. This is ready. That's absolutely happy. Bugger. So if we hold down these two buttons, power this on. So firmware version 5.0. Hardware version A19. 0100 is fault 1 has occurred 0 times. '21 has occurred once, 22, 25 twice, 26 once. 1, 2, 3. That's it, they're all set to 0 now. So, what we can do, there you go, went up to 95, 96. It shouldn't be anywhere near those. 97, 98. These are not valid temperatures. 100C, then back to 93 as though it were working properly. Fortunately, everything got a little bit delayed at this point because of the hand accident, and I kind of have missed filming fitting the replacement pump, but it's literally taking one out, putting the other one in, so all good to access. Other than that, no real problem. And look, so I've replaced my pump. The last thing I've just done actually is just look back on my video to make sure that this little T-shaped connector here, this is an overpressure valve for the water side, and I had to take that off in order to change the pump. So I've just kind of double checked on one of my earlier videos when I unscrewed the end here, because this side here, so this is the top of the pump coming out, and just here, this is the main water flow up here through this valve. So we've got the pump at the bottom pumping high pressure up through here and out here. Now this thing to the right, the thing actually returns back to the cold water tank. And what this is actually, the idea is cold water comes in the bottom and it circulates back through there. So it can actually release pressure, overpressure, that occurs up here. If you push too much pressure up here, it goes down there instead. What I've just done with this right hand side, so you can see we've got a clip and a big tube coming on. Then there's a nozzle sort of sticking out and a clip on here. This clip just here stops that nozzle from rotating, and that's because that nozzle is actually a pressure adjuster. So I've just gone back over my old videos and made sure I've readjusted that pressure adjuster to exactly the same position that it was in from the factory. Okay, cool. So that should in theory work. No, it doesn't work. Now what I've done now then is I've just removed this sleeving off this bundle just here. And I've done that because it gives me access to all of these points here. So a lot of these are coming down off the Triac board, and then they go into one of these connectors, and then they bugger off through this heat protected braided stuff to one of the boilers. So the blue is common to all three boilers. So there are two boilers, and then there's a group head heater as well. So the blue is common to all of those. The red is for the hot water, and the brown just here is for the steam. So one job that we can do fairly easily is we can put it into ohms mode. So this is my boiler. I'm just making sure everything's turned off. Yes, it is. Before I stick this in here, and yeah, look at that, 99 ohms. So that cable's going all the way through the boiler, through its heating element, through the thermal fuses, etc., and it's fine. So now let's go from the blue to the brown, and this one should be about 40-50 ohms, something like that. Oh, can't get in there. Oh, there we go. Okay, and there we go, 46 ohms, and it should be about 44, 40 to 50, something like that. So I'm cool with that. Okay, obviously they're a bit tricky to probe, and thin connectors like this I've made it a bit easy for me. So I'm going to put it on volts AC now. Now the other thing that I've done is just here I've just put a amp meter on that. I'm going to turn it on at the mains without turning it on anywhere else. And yeah, I'm sure you can't see that, but anyway. So if I press that, it tells me we've got 244 volts and we are drawing 1.1 amp, and that absolutely shouldn't be happening. There should be no current being drawn whatsoever at that point. So let's get this guy in here and we'll probe this red one. Now I've got AC voltage probe at the moment. Oh, look at that. So there you go, 122 volts. So that's half of the expected RMS voltage. Let's turn this off straight away before we do any more damage. That's half of the expected voltage. So what's happening there? Almost certainly on the Triac board, we are only switching. We are switching when we shouldn't be switching, but we're only switching half of an AC cycle. So we're doing like a bump, nothing, a bump, nothing. So we're getting half the amount of RMS that we would expect. So that is a dead cert that that is a Triac. So we can feel a fair bit of heat emanating out of here. Whew. Let's make sure this is turned off at the plug socket. We do not want any little accidents. Alright, so I reckon this is the Triac board under here. It's almost like they put it in a nearly accessible position. So here's our Triac board, and we've got loads of opto isolation. And then we've got a bunch of heat sinks down this end. So we've got the actual board out now. 2 screws for that. But seriously, these wires are soldered on, just in case you ever fancy replacing this Triac board. Presumably they go down here somewhere and have terminators on them. So there's no obvious explosions on these Triacs, at least. Not necessarily the same type of Triac. Q6015L6. Okay, so there's our data sheet. Obsolete, of course. But so 15 amp 600 volt Triac. So I decided to replace all of the heavy duty Triacs and also pick up some of the Optocouplers just in case, and these are the part numbers that I actually ended up getting because they contain the relevant snubbers and they've got isolated tabs and all of that sort of stuff. So they're good drop-in replacements, and they're all either the same kind of current or better. These 3 devices here, which are all Triacs, but testing a Triac in circuit is a bit, you know, it's a bit how are you doing, really. And so So the results I got from that are a bit, yeah, who knows. So I'm going to just unsolder these, pop them on a tester, see what I get from that. And I might just replace them anyway, because they didn't cost a lot. I've got plenty. And yeah, and it doesn't necessarily mean it's these. I mean, in truth, it may not even be the board. But if we assume it's the board, the most likely candidate are these Triacs. And then we've got some opto isolators and here, and also all the way along here. Now, I think that 3 of these are operating these little tiny transistors down here, which I'm not going to worry too much about. This is the power end that I'm worried about. But these opto isolators here, these also contain Triacs. And they're actually designed to drive Triacs. So yeah, we'll see what happens with those. I don't have this exact part. What I do have is kind of the next voltage and next current up. So I've actually got a slightly superior version of this in stock. So if needs be, I might just pop those off and replace them anyway. Right, let's get on with taking these off. So when I do replace these, I do have to be cautious because when I put them back in, these holes do have to line up with the heatsink, of course, in a flat plane so that it can be bolted onto the top lid again. So a little bit of cautious. Now, these are bent. You can kind of see, let's see if I can just zoom in a little bit. So the center one, the pins go thick out the body and then go thin to actually be soldered in place. And it's folded where the thick to thin transition happens. So that's that one. And then the other ones just have to kind of follow suit. So let's see if I can get this out. So I'm going to undo this. I think this is a removable plug. Please be a removable plug. And yes, that is polarized. That's fine. I'm not going to get in a mess with that. And I'm going to remove this one here so that this can actually fold upside down. Put this in just so that I don't get any solder inside, because I'd kind of rather not mess around trying to remove this entire board if I don't have to. So let's get the desoldering station up and running. There's a lot of solder on these. I'm kind of just ignoring the conformal coating and hoping it will just kind of go through. I think there's a conformal coating on this. It looks like it's been brushed on. Come out. Okay, so there's our first one. C6015L6 PCH 9N. So you may or may not be able to get exactly the same part. I did. If you don't, you must ensure this tab is isolated. Otherwise, you could run into a few problems. So while I'm in here, I'm just going to replace both. So I'm starting off with these 2, and then I will replace the other one in a second. The reason I'm doing 2 and then the other one is because these 2 are the same type, and the next one is a lower rating. And I want to replace them all with exactly the part that Sage or Breville originally fitted. Alright, let's get these bends done and get them right. So heatsink tab up. And the first one bends right on its junction. Position them carefully on the board this way. Place the grip on this side and bend them down. So now I'm happy that this will fit on the board and the heatsink will be in the right place and everything. Let's just repeat that with another one. Let's move this forward so we can see what I'm doing a little easier. Just wiggling that in, nice. And conveniently these do sit hard against the board, so I don't have to think about spacing them out on the board, which would have been a real pain in the bum. This one is hard to fit in, and the reason is it has to go down the side of a little bit of squirted on insulation. But we are in. Actually, I think with this one I might just use a bit of insulation tape just to hold everything in place. While I do my soldering. So these boards are £70–80 each. And the parts that I'm fitting are probably about £7 or £8. These are by far the most likely thing to have gone on this board. So if this doesn't work, then I will have to revisit, of course, but okay, now all I need to do now is, after all this time, remember how the hell it all went back together again. Okay, so that didn't quite work out, so I have gone back and replaced all of the Optocouplers. I just replaced the lock because I've got a pack of 10, why not? And that seems to have done the trick, I think. Okay, so I've got it all joined up and it is currently running on standby, and it is drawing about 0.3 amps thereabouts. It's switching back and forth between about 0.3 and 0.4, which probably feels about right. I mean, he's got various things running, fans for example in the back here. We've got bright LED displays, LEDs down here to light the water and so on. So yeah, it doesn't sound like it's a million miles off what I'd expect. I've allowed it to reach temperature. It's reached 93, which is its pre-programmed factory set temperature, and it's shut off. If this meter here is joined onto the steam element, this meter here is joined onto the coffee element. So if I dispense some steam, that's coming out absolutely fine, and we see the steam element has just turned on to compensate. Turn off the steam, and hopefully fairly shortly, yeah, there we go, and it's gone. Right, so let's dispense a couple of coffees, or a couple of normal coffee from the boiler. There's the main pump coming in. We've got some water coming out the nozzles. Interesting, it's a steam boiler that's come on. It almost works. By that I mean it turns on, it comes up to temperature, it stops at the right temperature, the elements turn on and off appropriately, and it dispenses steam perfectly, and it dispenses hot water, but not with any pressure. And when I turn it off, what actually happens is I get a lot of back liquid coming through here and down this pipe just here, which is actually the overpressure pipe going back into the cold water tank. So I'm going to bet that this valve here, which I carefully restuck onto the motor, has got a problem, and that actually might be part of the whole initial problem in the first place. So today I'm going to replace that. Hopefully, I don't know if I can replace it in situ or whether I'm going to have to take the pump out. And here's my spare part. This, funnily enough, is the actual single most expensive spare part for the whole thing. Slightly more expensive than the pump, but I had a bit of difficulty sourcing it, and it's already been adjusted by the looks of things, but we'll test that and find out what's going on there. So I'm going to replace that, and then I will perform a pressure test to see whether or not we are anywhere in the ballpark. And I'll talk a little bit about the pressure test when I get there. Okay, so this is cold. I've let it cool down completely, and I'm going to start stripping this down now and try and remove this without causing myself a whole lot of trouble. Let's just pull that back a bit if I can, just to get a bit more clearance. So the first one is this pipe up here. So same as usual, one of these little circlip things. The pipe should just pull out. It does. Just pop him out of the way. And in the top of there, there's a little red O-ring. Perfect. Now I'm going to replace that O-ring because conveniently this kit actually comes with one. Now we need to remove this end, and I need to slightly fill out a pair of tweezers to get this clip off. So just move this clip back. This pipe should just now lever off without too much trouble. Okay, cool. Now the question is, can I manoeuvre all these pipes sufficiently out of the way so you have to turn this off? And the answer is no, I can't manoeuvre the pipes in order to get that off. I'd have to split that out. We might be able to get it off if we pop this. So, just as a quick test, what I'm going to put my finger over the hole here. This is the one that I've just taken out. I'm just going to blow in this end here, and there should be nothing coming out of it at all. Yeah, and there is some air actually coming out of that. Try it with the new one. Oh, nothing at all. Perfect. So, yeah, definitely a problem with that device. Interesting. Now the question is, do I take the end out of this? Okay, so I'll just pop the end off. This is the locking mechanism that just kind of stops it unscrewing more than it should do. And I'm going to put a line. Okay, so I've made a couple of pencil lines. They're a bit faint, but they are there. Hopefully you can see those. So just count this as we take it out. One. That's 2. 2 3/4. Okay, we can see a little valve down there and a spring. Okay, so I've taken the nozzle out. I do not want to lose anything that's in there. There's a spring and stuff and a little ball in there. I don't want to lose them, so I'm just going to pop that tape over the end, just so I don't accidentally lose that while I'm working. And we take this washer thing here. Now this goes, so let me just show you what's on the end here. So we've got a nice screw thread here, and then we've got a rubbery silicone washer just there, and then this fits neatly over that silicone washer, and it's got a cup, and the second part of the cup will fit over the top of this. So we just need to put it on there, get the screws nicely aligned, and just start the process of winding it on, making sure we don't get any cross threads or anything stupid like that. And we'll wind on nicely until it becomes pretty tight. Keeping going. And now the bottom layer is starting to turn around a little bit, this piece. So we'll grab the right spanner, hold him, and just tighten this properly into position. We want it pretty tight, not stupid. Okay. So that's the 3/4. 1, 2. Everything's lined up. It's in the same degree as it was before. We slip this on. That's going to lock that in position so it can't turn anymore. And I'm not going to do it just for a minute. Ultimately, I will, when I'm happy that everything is suitably in place. That's it. Then I will put a cable tie around that to ensure that it can't just sort of pop open. That's it, he's back in place. Looking good. Now we'll just pop these tubes back where they originally were. Cool. And take this pipe, apply the new O-ring. Push him home. Slip in that, slip on that. Make sure my pipes are back where they're supposed to be. So they look okay, they're looking fine. Alright, let's turn it around and give it a go. Okay, that should be on tight now. Let's hope for the best. Sounds good anyway. Let's still got a bit of a drip, but we're behaving better now. 6, 7, 8, 9. And I was aiming for 10, and we did pretty well there. We have got a bit of a leak, so 9 3/4, so 8 and 9.5. 9.5 we've got there. So you know what? I'm going to leave it at that. That looks pretty bloody good. I could just wind in just a tiny bit on that adjuster. Perhaps a quarter of a turn. But given that I've got some leak, yeah, I'm kind of happy to go with that. Okay, so we've got the pre-infuse, 7 seconds of that. We should increase our volume. Now I'm looking for a volume of about 50, and hopefully this is going to take about 25 seconds. And we'll stop it at that. And I reckon that's pretty good. That's a volume of 53, or weight of 53 grams. And the volume there is, well, you know, it's kind of hard to measure because of all the frothy crema on top, but yeah, it's about 60-ish to the top of the crema, maybe 65, nearly 70, and we can see a good thick crema on there. Could do with some slightly fresher beans, but yeah, pretty good. Okay, and there we have it, one working coffee machine. So it's been quite an interesting repair for me, quite a lot of fumbling around trying to understand what's going on, but got there in the end. So I think the worthwhile stuff was certainly cleaning the probes, fitting the O-rings, and why not while you've got it open. This has done about 5,000 shots so far. So replacing the O-rings, they're going to get brittle after several years. So that's a good idea. It turned out I think that replacing the pump wasn't necessary. But critical was actually replacing the overpressure bypass valve, or OPV. And I would say if you're doing anything with the pump, replace that valve at the same time, because you know it is ultimately going to wear, and the time you really want to do it is now, when you're actually doing work on the pump and you've got good access. In this case, it turned out to be largely to do with the Triac board. Triboards are quite expensive, and I was able to source and replace both the Triacs and the Optocouplers. Turned out it was actually the Optocouplers, not the Triacs in this case, but you know, just replacing all those components gives a lot of confidence. So anyway, hope you enjoyed this video. If you did, don't forget to give it a thumbs up, don't forget to subscribe, click on the bell so you get notified, and I'll see you next time. Bye for now.